And we need to share our screen, right? Okay, wasn't that fun and exciting? Thanks everybody for joining. Before we start anything, I want to thank you, Dr. Brania, for allowing us to be a part of your curriculum. It's been a pleasure to me not only to teach linear algebra, but learn, right? That all this technology that we have basically is just industrial linear algebra at scale, basically. And you'll see the same thread that runs through this, the same math thread, I should say, that runs through this machine learning class, runs through robotics and quantum computing. I'm trying to let the people in, but it's not letting me. So let me stop sharing and maybe do that. Oh, it's a note taker. Nope. Okay, good. And thank you for that. All right. So now we have everybody in. Let me try to share again. And I think I saw somebody needs permission to share. Okay. Yeah, so let me close this. Come on. Things with dealing with a Mac. Here we go. Let's close that.
Good morning, everybody. How y'all doing?
Yeah, good.
While we're waiting, does everybody want to introduce themselves real quick? I'm Nolan Code, Executive Director and Founder of the Atlanta AI Robotics Initiative. I think just about everybody knows me at this point.
I'm Kid Kong.
Who wants to go next?
Founder. Can you hear me?
Yes.
I'm Kid Kong, the founder of Tecmo Sports. It's a Warhead is the name of it, but it's a illuminating football helmet.
Okay.
Trying to see if
My name is Daniel. I work as a robotic software consultant for a stealth startup. Experience, yeah, that's me.
My name's Eden Rohrbaugh. I'm a Google Cloud customer engineer based in Atlanta. I work with early stage startups in the area, and yeah, excited to be working with everyone here.
Great to meet you guys.
All right. So now that we got everything going, let's get going now. Okay, let's go back to sharing the screen. That'll have to do for now. So why, first of all, who remembers the use case in general? Omar, I know your team lead. Do you recall the use case at all?
Yes, it's essentially just to detect failures within a data center. Data such as temperature, machine could be at, etc.
Quite good. So I guess the question then becomes, why am I having you do this, right? There's something called the engineer's folly that you never want to do, which is put something out that you think is going to sell in the market, which only you think it's cool, right? There's several reasons why I'm having you do this. Number one, it's where the industry is going, right? I know generative AI gets all the buzz or what have you, but physical AI is where we're going, right? Running the AI closer to where the data is being run, which is what this project represents. Edge AI as well, or the essence of physical AI, which is showing machines how to interact with the real world, how the real world works. Also, part of this is world models. Daniel's going to get a little bit more into perception and other things that the world model represents. But I also think that's where we're going as well. And I want you guys to get ahead of the trend as opposed to being behind. And then lastly, I think it's interesting. I remember we had to pivot and sort of use digital twins, twinning, I should say, because with the lack of GPUs, you weren't going to get the full amount of data to predict failures. And synthetic data digital twinning, you okay? Synthetic data digital twinning is also where things are going. So I'm glad you guys have involvement with this project and all the pieces kind of fit in play for where we're going next month in April to the sort of VQE, reinterpreting, taking lithium out of the environment with quantum AI and high performing computers. And then in the fall to Dr. Joseph's class with robotics. Do we have any robotic enthusiasts in here, by the way? What just happened? I see it on here, but you guys aren't seeing it anymore. Anything in particular I need to do?
They're not they're disconnects.
No, well, let me.
I mean, where they are.
Yeah. No, the cord is still in. Looks like it's in. Anything else you could think of?
Oh. So I don't know why it's doing that.
Sorry, folks, more technical difficulties.
I haven't adapted to.
Because we're having so many technical difficulties, when we're going to get this adapter, I'm going to go through my part, and Eden, you can start on the Vertex AI. I was just saying that we're probably going to spend the majority of the time in there in the project anyway.
Mm-hmm.
So all good. So thank you, Eden. I'll let you run to your next call. We'll touch base to see where we can set that workshop up to work with the student schedule. Daniel, you're up now for the real hands-on.
Yeah,
Thank you, Eden. We'll talk again soon.
Yeah, thank you. So we'll just get hands-on. I'll share my screen. So just a moment.
And now that she's gone, sorry guys. I know that NVIDIA was supposed to be coming, but they canceled last minute. And when you're dealing with the superstar, you're on the superstar schedule. So we'll get them rescheduled. We have Microsoft at the end of next month. And sorry, I didn't get the robotics enthusiasts in the crowd.
Okay, so can you all see my screen? So the first thing we're going to do, I believe we have a Google Cloud account already, and we're on the project HMTH391. So you can just this link, if you go to it.
I know the 7 students for sure are in my Google Cloud environment.
Yeah, so if you're there, you can just go through it.
So we're supposed to be following as we go along, correct?
Yes, exactly.
That would be for you guys.
So like now currently I'm on my here. This is the Google Cloud. So you select the project. I don't know if I can see you guys screen or something. Okay.
I can see yours, but I don't know if you can see ours.
No, I can see it. So this is the Google Cloud project that we are working, and we are using. You select the project.
Did everybody get the link, or do we need to go back to it? Go back to the initial link, please, Daniel.
Okay. So this is the link. Let me just show it on the screen.
Yeah, and put it in the chat too, please.
Yes, sir. Is that checked? So just get there.
And that
You'll
provision
be
for 20 students, I believe. So I can count how many are in here.
Are we all there? Can we see? Are you able to locate the?
Are we all in the environment? Oh, okay. Can you put it in the chat one more time, please, Daniel?
Okay.
The link? Because some people just joined and are just
Okay.
joining now. Thank you, sir.
No worry. So
Keep going. Let us know if you're in.
are you all in now? So I don't know if they've all been set up to the accounts have been set up to the HMTH project.
Okay.
Okay.
A few people are a few people in the editor.
Are you guys able
Yes.
to?
Okay. I've seen some thumbs up. Keep going.
Okay. Can you all in the editor? So can you locate the project? Can you see any project like HTHMTH391? Have you been added? I think
You said he was saying, can you find that project in the editor and can you see it? I'm trying to
so
turn up the
look,
volume
if you
down.
go down on the shell, if you click under, you will see the HMTH39. If your email was added, you should see this project, HMTH391. Anybody?
Do you see the project he's referring to?
Can
Say
I
the
get
name of it again, Daniel.
That's the HMTH391 project. Just as a drop down, you should see that project. If you sign up with your email that you sent over to me, you should see that. At the drop down of the just here, I'm clicking here, you see that project because you are been added to it. Kennedy, can you see that?
People are still joining for some strange reason. All right, here we go. We're adding more people in.
Okay. If you can see that, just give me a thumbs up so I can know that you.
Yeah,
You
give a
can-
thumbs up. I can see you in the call.
If you can see this terminal, just by clicking the shell, you can see this VS Code editor, and that means you're in the right place. Then the next thing you need to look for is this project that you see the projects here. Is there anybody have any challenge? Can you see this?
Just say it in the call.
Sorry?
For me, oh, never mind. It says get started with code OSS for the web. Is that what we're supposed to do there? That's what I'm looking at.
So this is where the project is on where I build everything on. Have you all be able to see this project here? Just you click this drop down, you will see the project you have been listed. If you log in with the email which you gave to me, so I think you'll be fine.
And there's an email in the chat that needs to be added too, it looks like.
Does anybody, okay, some
Just say
people
your
are,
questions in the chat. He can hear you. In the call, I should say.
sorry? Has some people been able to see that drop down? Okay, this email wasn't part of it. Let me add you immediately.
He's adding the people in the who are sending the
Because I
email.
didn't see some
If you have any
emails.
questions, either put it in the chat or just say it in the call.
Okay.
Meanwhile, can anybody see the project that he's referring to in the drop down? I see a few people can, right?
How many people can see the project?
About 2 or 3. And there's
Yeah, that means
20
because they didn't send their email. That's why. Okay, so that's where I'll add you now. I'll just run a script. I'll add you all. Don't worry, no fears.
He's gonna run a script to add you in the system.
I'll add you. Don't worry, just a moment. So just drop your emails, everyone, so that I can add you one after the, because I just so once I add you, you reload back into the emails.
System setting. It usually comes up here. Yeah. And
So okay, just a moment so everybody can follow. I don't want anybody to be left behind. Where are the emails? That's one email here. Okay.
Mhm.
Make sure this I'm coming in just a moment. Okay, makes sense. Well, then that's okay. Your email cannot be added. Let me just type that. Is that okay? Ryan's that email doesn't exist. Okay, so I've added one person. That's CSS Ryan. Who again? Jalen. So if you refresh, you should see yourself there. Maybe just give it like some seconds. Okay, granted access. Good. And you also But how many people can access the project for now?
How many people are in, can see the project for now? I saw maybe 2 or 3 people. One. Okay. So maybe 4 or 5 people? What about everybody else?
I'm adding just one of the people.
Got some thumbs up, some down, but because we only have like 30 minutes, we have to get going soon. What's up?
Okay, so I'll try to be fast. So.
I understand. We're adapting on the fly.
You I've added you also. Should get this script. So for the people who have added, have you noticed you are able to access the project?
A few people are in. If you have,
If you're on this place, just do exactly what I'll be directing you. Okay. So next, you want to type bash, bash, B-A-S-H, B-A-S-H.
bash.
Let me put it on this. Then space, deploy. Type deploy as if you're typing deploy. D-E.
Put in the
Anytime
chat, bash and deploy.
then put a slash, a forward slash, then press X. As you press S, press tab. It's going to complete it. S, letter S. Then tab. So you can see type T, then tab. T and tab. Okay, then run that. So these are, I prepared all these scripts. That's what we call cloud. So you are able to access everything based on added. So follow whatever he's doing. So you can see that he's uploading the USD asset, so you can have it available for you. So it's running on your computer, and it's installing all the Python dependencies you need to run. So that's a way of packaging a program. You've packaged all the dependencies, the libraries that you need to run. Okay.
An automated script so you don't have to do it yourself manually. Saves you a lot of time and effort.
Yeah, so I think we need to take a class on how to write scripts, because I wrote them. So everybody just do what he's doing. If I've added you, be able to do the same thing he's doing without stress.
What, Daniel, while that's loading, talk about the world model a little bit in terms of perception and things that are different from the transformer.
Okay, so just to give you a more context, first of all, we need to understand everything from start to finish. Like we wanted to, the first stage, we wanted to start the project. It's taking some time. Okay, it's not done. I don't know. Because of the, I think because of the weight of the USD file is about 9 point something gigabytes. So it's trying
We lost you there for a second.
Yeah. So let me start from the, just for you to understand what we are doing from, why did we need the digital twin? We want to data center failure. if I ask you a simple question, when last did you see a failure from a data center in the real world? Very rare. So you cannot learn about failure just using real world data centers. So you build a digital twin. Digital twin is built on NVIDIA Omniverse, which I've packaged. You understand? So why you are seeing no file is because you're not in the right directory. You need to enter into the DC directory. That's why I say no such file. You should be in CD DC word models directory. So you should need to be in the right directory. Okay, you are correct. Sorry. So the digital twin, it's like a physics behind like the real world, you know. So we simulate behaviors. No space. Yeah, you have run out of space. Sorry. That's why we needed so much space in this. I'm sorry about that. So let me just give you some. So you can reduce the space. Let me give you the command you can use to remove some excess, some cache memories. So you can just put this. So you would type
Sorry,
this.
can you say if you said again? I didn't see it. Yeah, we missed what you were talking about.
This will remove some excesses on the all the cache. So it will remove all the cached files, so you can have more space to run this stuff. Okay. So that should do that. So what we did is, what I'm doing here is, the data center is having a digital twin, and I'm able to simulate it for days, like as if it's real world. But now, because it's a simulator, I can make the time start faster. So I lifted up all those stages for you. You are not seeing it, you're just seeing the end product, which is the CSV file. So it's like it worked for 30 days. I was able to, you know, trigger it with different temperature, rack, and everything. So there are 48 racks in that twin. So most times it's good to model the digital twin to look like your real world environment. So if you have 48 racks, you have this, it should be a twin, like the words, a digital twin. It should look like what you are trying to test on finally. You understand? So if you have 40 racks here, you should have 48 racks in the real world. If you have 2 racks here, you should have 2 racks in there. So you to model is a twin of the real world. That way you can, you know. Yeah.
Let me chime in for a second. I think that part of the problem is like the snake is eating the tail, right? Data is finite. Now we're going to start making synthetic data, which I was worried about overfitting. Everybody knows about that once you get down later in the model. But where we're going, especially with Omniverse and whatnot, synthetic data is where we're going. So might as well learn it now and get ahead of it.
Okay. So I didn't get you clearly, I think. Sorry. Come on.
Say it in the call.
Well, so you can talk about like synthetic data, like what does that describe? So like you will automatically like determine like what each individual person is. Like this is
I think that, and if you didn't hear it, Daniel, the question is, what's the meaning behind synthetic data?
Thank you. Very good question. Yeah. What's the meaning of synthetic data? Synthetic data means it's not data from the real world, but it's data that is gotten from a simulation that behaves like the real world. If I say, for example, a motor crash, I want a model to learn what a motor crash is. You may not see enough examples in the real world about a crash. So you can use a simulator to create as many crash as possible, so the model can know what a crash is. So synthetic data is a data gotten from a simulator or a digital twin, like the USD that you saw uploaded. So because failure is not something that occurs in real life that much, our model learns from experience. You know, deep learning is all about learning from experience, from data. So because it cannot see much of it captured in the data set, we will use a digital twin and manipulate failures to occur in that physics environment by changing
Everyone
parameters.
clear on that? Because you guys only had 3 GPUs, we had to simulate failure because you won't get enough data of failure from your lab upstairs. Basically.
Yeah, so that's exactly what we are doing. So you can't just cause a failure. It happens based on some conditions, and it's not something that you can trigger. So a digital twin becomes very important. It's still installing. It becomes very important to do that. So once you do that, you have a data set. That synthetic data is coming from a digital twin that resembles the real world. Then you have a data set. Then you train, which is the next step. There's still no space. Oh boy, why is there no space? You have I thought they gave these people some credit. Oh boy,
You did.
I don't have enough space. Okay.
I verified it twice before I left.
Okay, so that's it. So this, if you run this, if you run through the GitHub, you will see that there is you will generate that CSV file. It's an Excel file, which is the final output of the data, showing the different parameters of the data center and where it fails for that 30 days. Then we will train them, which you see you train on Vertex AI, just like the lady was telling us. The script 8 uses a Python script. If you look through the code, you train on Vertex AI, that data set that you got from the digital twin. It will now produce a final checkpoint, what we call weight. In normal mathematics, you have input, then you give the system the function, then it gives you an output. But in deep learning, you have input, you have output. You are trying to learn the function that operates those things. So that function is called the weight. It's like weights and bar. So at the end of the day, you have a weight file in .pt, which if you look to the script, we converted it to an Onyx because you're going to run it on a Jetson. So .onyx is .onx. It's a neural network exchange file that helps you to deploy the weight on the Jetson.
We're not going to have enough time to load it on here today.
So that's what you are going to do. If you can still try it out, to remove those. I don't know why there's not enough space for you guys on the. I don't know. That's more like a Google something. I don't know why. It's supposed to have enough space.
We'll get through it today, so you guys have access. Yes, sir.
Yeah.
Not everyone should have access.
Oh, he said if they refresh, they should have access.
Yeah, everybody should have access now. If you just follow the steps. So the steps is found in the student instruction file. Everyone should have access because I think I've added everybody's email. So everyone now should have access. Let me so
then you just want to keep going through the end so people will see what it looks like? Because we only have 10 minutes left.
Okay, no problem. So so the next thing is that I want to train the model I want to train it. So after generating, like, see this is, I've generated the.
If you're showing something, share your screen, please.
Okay.
And you're gonna lose my muscles I haven't had in a while. I haven't done a demo in a while. I forgot about Murphy's Law.
Okay. So can you see my screen?
Yes.
So, okay. So for this one now, you want to train the model. So we are running this Python script to train. It's using this is first of all to generate the data to get it, because I've already done it before, so it's already cached. So I'm just trying to show you because I've run this already. So is generating the data set. So it's already cached. That doesn't take much time because I've done it before. It's already cached in the memory. So that's going to give us the data sets for 30 days, with all the parameters and stuff. So we generate the data set. So generate data set is coming from the digital twin, not from the real world. Because why are we not using the real world? Because failure is not something you can trigger naturally. It's not something you can just trigger and know. You won't have enough samples for you to learn about. So a digital twin becomes handy because it can give you, so you can see label, cooling failure, disk degradation, the percentage of things caused, overheating. This information are coming from the USD file, which I loaded, which was, took all of the space. It's about 9 point something gigabyte, took all the space.
Real world conditions. That's why it's called
Yeah.
physical AI, the physical conditions
Yeah.
of the real world, right?
Yeah, exactly. So then once you generate that, we want to train, this model. So we can upload this to the cloud, which I've done all this before, so it's already redundant. So I'm sourcing the environment. The environment is where I set all the environment parameters, the ID, everything. So once I'm done with that, I put it up, that file, this CSV file, I save it in the cloud so you all can access it. So you can still pull it from the cloud, if you want to.
You have any issues, email
I'm not,
us.
okay, I think that's an error. So then the next stage is to train on this CSV data that I've done. So the training, I don't want to use this local training just to see if everything is working, but I want to train on Vertex AI, which is the cloud platform. This will take time and it will submit the weight on the platform. So it means I'm using that CSV file and I'm using the DINO, because if you look at the Vertex AI script here, I'm calling the DINO model to be used to train. So that's where I'm importing it, and I'm using it to train the you can see why I find the DINO model here. That's it, the encoder here. So you see that all on the don't be too careful about understanding this for now. It may be too high level for now, but later. So that's it. I'm just trying to show you how it works through, how we run through. So I don't know. So the next thing is we want to train with this. So every time I want to train, I source the environment file. The environment file is it that contains all the parameters that I've defined. So environment file is, if you use Windows, there's what we call environment variables. Most times in Windows, you need to restart to open that environment variables. Maybe you made a change, it tells you to restart. Those environment variables are things that are by default loaded when you restart your system. But mostly because Ubuntu, we are running on Bash power system, which is similar to Ubuntu, it's easy for you to source it. So you can easily restart, initiate the configurations. So there are some things you have configured in a file. Once you source it, it reinitiates all those variables. So I can still remember what every variable is, and you can call them in the script. So that's what a sourcing does. This is like Linux.
Daniel, hold on for a second. Does anybody have any questions? I see some people following, some not. Like where are we at with this? If we need to follow later, let me know. Because I'm gonna stand up the environment for at least 48 hours, because this wasn't fair. We're supposed to do everything here.
I probably need to schedule here because I'm having storage. So I'm gonna space good.
This is recorded, right?
Yes.
Okay. So,
Yeah.
I don't have any space. I need like clear space.
then space area. Space are only when the batch script.
So Daniel, they're running into storage issues when they run the bash script. They have to empty out some local storage, and it's taking up all the bandwidth, it sounds like.
Yeah, so I think that's what the issue is. I don't know the allocation. I've tried to, I don't know what the allocation they give to the student. I really don't know how to go about that one. Maybe she could ask the Google. I don't know why that is. Because they're supposed to have enough. I don't know how much they allocated to them to use power. So that's one maybe given the issues. Because now they can't. I think you just need to. I don't know if they expanded the stuff like you said, but it's supposed to, because it worked perfectly for me, and I don't know why. No, so I don't know,
Alright,
but just
So,
but what?
right, hold on. So a lot of you guys have Crown Forum too, right? So we'll stop here.
Yeah.
What's up? Go
Okay,
for it.
but you can just follow through the training script. You should have it already. You can start from phase 8. If you run phase 8, it should run without issues. You can try running, because now everything I've done is already stacked up for you to do. So I've stored all the CSV files. So if you run this Python script, you should see the training. So this is phase 8. You can run it.
Okay,
Yeah,
Daniel,
you
hold
can
on,
see.
someone's speaking.
Trying to compensate for that. So remember you mentioned about the event on the 30th? Well, you guys will actually be traveling to Microsoft for the event. And because of that, you guys will need Microsoft's going to need like your names and a little bit of information to register you for security. So I haven't posted this form to anyone else yet. I'm giving everyone who came here 24-hour head start to register for the form, because I believe we only have 30 available spots. And 4 of those are going to be reserved for 2 Spellman and 2 Clark. So you look on the right of this computer as you leave, please scan this form and register. There's a couple other people I talked to. Remember, you only have 24 hours before I release this to everyone else, and it's gonna fill up quickly. And there are about 20 people in this room, so if everyone does it, it's only gonna be like 4 more. So please get informed.
I was trying to hold off until she left, until I said the Microsoft garage. but yes, more hands-on. We're gonna recreate the lithium experiment.
Will transportation be provided, or people just carpool?
You have to carpool.
Okay. And
Food will be provided though.
Where enough.
Right. I'll talk to you about that later, Daniel. We gotta start getting going to that VQE stuff. But
Okay, no
one thing
problem.
at a
Thank
time.
you so much. Yeah.
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 Kid, you want to make your
Okay.
announcement too? 10 o'clock.
10 o'clock. And so we'll send a bigger email out about that. So you guys get a head start.
Kid, are you still there?
I am.
Yeah, you want to make your announcement too?
Announcement of the helmet.
Yeah, we sent out an announcement to Dr. Sims about his project and the sprints that he's doing with his helmet. But you can say it better than I can.
Oh, so just don't tell them about the helmet.
Sure.
Yeah, guys. So hey, first of all, great to meet you guys. I look forward to working with you guys. That will be a part of my project of creating this illuminating football helmet. This helmet is I've been working on this helmet for the last 10 years. I have a patent with one on the way back. So here in the next couple of days will be 2 patents on this helmet. But this helmet essentially just first of all, it was designed for safety. It was built to keep the players safe, to know about the players, to collect the data and analyze the players on the field. And as I continue to be creative and to evaluate the game of football, and what I like to do is make this thing, more interesting for the fans, being able to change the logos and the colors on the sides of the helmet. Being able to
Maybe we'll make a video to show them. Sorry to interrupt you, kid. Maybe we'll make a video to show, because it looks a lot cooler than describing it. And his company is Physical AI, Edge AI, that we've been talking about, right? We're trying to work something out with Clark and their smart stadium. So those who want to participate in the sprint, you will be compensated for your time. We're starting cohorts of about 4 to 5 students. Real world physical AI, real world edge AI. I sent it to Dr. Wesley Sims, and he sent it to like some of his rock stars, but I want everybody to be a part of it, because this is experience you can't fake on your resume, right? So. Thank you, sir.
Well,
All right, I'm gonna end the call. What's up? Okay. Oh, go ahead. Make your announcement. Go for it. For those of you who dropped and dropped, thank you all. Students,
Yeah,
stay,
thank
'cause
you.
homework
Bye.
announcements to make. Thank you, Daniel. We'll talk later. Thank
Yeah,
you, kid.
thanks a lot. Yeah.
all right, guys. Talk to y'all soon.
Yeah. Okay. Thanks. Yeah.
Yeah, thanks again to Nolan for hosting the event today. Working with ACC and MCC to get it done. I do have an event for ACC I wanted to bring out. We're going to be having another panel, but this upcoming Tuesday. But the theme is really going to be non-suite. So for anybody that might have an interest in product management, design, maybe even corporate finance, it's going to be a really good discussion about how to get a job even in the climate of this job market where things are a little harder. I've been able to get 3 people with full-time offers at Microsoft, 1 person that's interning at Roblox, and another girl that's interning at Warner Bros. So a lot of good information is going to be talked about. Opportunities are going to be spread. So ACC is going to send out some more stuff, but I'd love to see everybody there. I think it'd be very beneficial for everybody. So yeah, thank you. Yeah.
All new board members for ACC and tech coaches, you can please state that.